Section 5.5, binomial distribution. We're going to start with a new calculator function, and then we'll start talking about what the binomial distribution is. So we're going to start with this new function. It kind of looks like a fraction. It's n over x in parentheses. We read it as n, choose x. I'll show you on the calculator in a moment. It basically tells us the number of ways of choosing x objects from n. So like if I have a class of 35 students and I want groups of 4, this tells me how many groups of 4 I can make. It doesn't mean groups of 4 at a single time. It means all the different combinations of a group of 4. So there's actually a lot of options. But let's figure out how to do this on the calculator. So I'm going to type the first number. I'm going to do 35. I'm starting with the one I just made up, math. And then you're going to scroll all the way over to PRB or PROB, probability. And then you'll see NCR. And then you type the second number. So there's 52,000 different groups, 52,360 different groups of 4 I can make. And so this is considering every single possibility. So 3 people could be the same and I only change 1. That's a different group. So there's a lot of combinations. So let's do the rest. So we're going to type the first number. And then I also have a separate video in case your calculator looks a little different. So you can see all the ways it might look on your calculator. But you're going to type the first number. So you always type the top number first. So I'm going to do 8, NCR 3. On some calculators, it ends up looking like this. Little subscripts, 8C3. Just depends on your calculator's notation. So 8, math, NCR 3. Cool. 56. So there's 56 different combinations when I choose 3 out of 8. 5, we'll do the same thing. 8, math, all the way over to PRB, NCR 5. And it's 56 also. And that's because when you make groups of 3 out of 8, you have 5 left over. So because 5 and 3 add up to 8, it kind of makes the same number of groups. Because every time you make a group of 5, you have a group of 3 kind of left over. So why don't you try the remaining ones? Maybe pause the video and just see if you can type them, and then come back and check that we get the same numbers. So I'm doing top number, NCR bottom number. So I'm just going to type them all really quickly. And then you should just pause and practice. Make sure you're getting the menus down. So for 52, NCR 5, we get 2,598,960. So tons and tons of options. Again, it's considering all the different combinations. 51, choose 6, we get 18,009,460. And then if you've started that next one, you do get kind of a strange number. So let me help explain that. 1.05 doesn't mean there's only one combination. Notice that E15. So that's like times 10 to the 15 if you know scientific notation. So it really means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 zeros after the decimal place, or move the decimal 15 to the right. It's a really, really, really big number. So this is going to tell us the number of ways things can happen, which is going to be really important for binomial. So we've done probabilities, but most things we've done can only happen 1 or 2 ways. With binomial, there tend to be a lot of ways things can happen. So we'll use this in a moment. So let's talk about what binomial is. So we're going to have n trials. We're going to do something over and over and over. The big thing for binomial is there's only 2 possible outcomes, and we call them a success and failure. So once you have more than 2 options, you cannot use binomial. The trials are independent, which basically just tells us that the probability remains the same. So all those problems where we had to change the total or change the number of people, those are not binomial because the probability is changing. So we're going to look at some examples. Flipping a coin. So that's 10 trials. So that'll be my n for my n trials. P is the probability of a success. So if you think about flipping a coin, the chance of getting heads is 50%. So P would be 0.50. And then Q is just what's left over because there's only two options. So Q will always just be 1 minus P, or also 0.50 because it's a 50-50 chance for heads and tails. Free throws is something we've looked at. That would also be binomial because they either make it or miss it. So if they do 12 attempts, that's 12 trials. So that's my N. P, again, is the probability of a success. So the probability of making it is 80%, so that would be 0.80. And then in this example, Q is just the probability of not making it, so whatever is left over from 1, which is 0.20. So this will kind of be the starting point for binomial. Something has to happen only two possible ways, success and failure. We repeat it over and over, and that probability stays the same. So let's look at example 2, and we'll go back to roulette. Technically, roulette has 3 options, but if we're betting on red, then red is the success. And then we basically just group black and green together because both of those are a failure. So we won't really consider black or green different colors. Either of those are not red, so we fail. So I'm going to do this one in terms of fractions in case we don't remember. There's 38 colors on the roulette wheel. You could just add these 3 numbers up. So the probability of getting red is 18 out of 38. And then the probability of not red is what's left over, 20 out of 38. And so we're going to play over and over and over to make this binomial. So playing 5 times means we have 5 trials. And we want to win 3 of them. So that means we're going to win 3 and lose 2. And the problem is there's lots and lots of ways this can happen before we can find this probability. So if we think back to our old chapters, we could just multiply, right? You win 3 times, and then you lose and you lose. The problem is there's more than one way this can happen. And so I kind of organized it in a table, and it's super tedious, and it would be really hard to catch them all. So we're going to talk about a shortcut. So you can see all the different ways. You could win, 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 lose, lose, win, win, lose, right? You can go through this. It's tedious. If you had to do this, you would likely miss some. But if you count them, there's 10 ways. And so what we end up doing is we times it by 10. But this is why we learned that new function. So that new function we learned will find 10. So go ahead and do 10. Oops, not 10. We're doing 5 games, and we want to win 3. So that's the same as 5, choose 3. So if you type this on your calculator, it's going to find this number 10 for you. So that's what this new function is telling us. It's telling us the number of ways it can happen. So 5 for 5 total trials, and we want to win 3 of them. So how many different ways can we win 3? 10 different ways. So that's kind of cool. So we never have to organize a table. You can, but you'll likely miss some options, and some of them are going to be even more options. So this new function tells us the number of ways something can happen. So we have our binomial formula. Same criteria. It has to meet this criteria. We have n identical trials, 2 outcomes only. If it has more than 2 outcomes, we got to do something else. They're independent, and P remains the same. So N is the number of trials. P is the probability of something that's a success. And success isn't necessarily good. It's what we're measuring. So a success could technically be bad. It's just what we're interested in. And Q is the probability of a failure, which is 1 minus P. And then we get this kind of scary looking formula. So the N choose X. As scary as it looks, it's just measuring the number of ways something can happen. P to the power kind of looks kind of scary. But I just remember that the power will be the number of successes. And then Q has kind of a scary looking power, and Q will just be the number of failures. So we'll see this in an example. If you look above, right, we have 3 wins, so that would have a power of 3. And we have 2 losses, so that would have a power of 2 when we do the formula. So let's look at a couple examples of whether it's binomial or not, and then we'll do a full binomial to get a better idea of all this. So if we're testing light bulbs that are defective or not in a sample of 1,000 light bulbs, this is binomial because there's 1,000 trials. and then it's defective or not. So there's only two choices. In this case, defective is my success, not defective is my failure. If I weigh 20 apples, there's 20 trials, but the weight of an apple, right, that's a continuous variable. So that's not two choices. There's lots of things an apple can weigh. Let me write yes and no as I go through this. If I count the number of times that the sum of two dice is larger than 9 out of 80 rolls, in a weird way, this is binomial because we have 80 trials and they're identical. And then even though we're looking at the sum of two dice, we're basically looking at larger than 9 or not. So there's only two choices. So larger than 9, 10, 11, 12 are all getting grouped together. Anything 9 or smaller is getting grouped together. So it's larger than 9 or not. Versus the actual sum of two dice, this would have too many choices. So hopefully that helps us see the difference. So this is just an introduction to binomial. In the next video, we'll actually do some binomial examples and get a better idea of it.